Let's have a look now at some examples of quadrilaterals and finding angles. So, first example, let's find the value of each pronumeral. So we've got the pronumeral letter V and the pronumeral M. And don't forget, we have to give reasons. It's important we do that so we can show our understanding. So, let's find the value of V first. V ends up being 110 degrees. They look pretty much the same. I can't get out a protractor and measure because they're not actually drawn to scale. But we can say that because it's a kite, and in a kite there's one pair of angles that are equal, and they're the ones here. Remember, I could rotate that kite around, so we just need to be careful. So these angles are equal because equal angles in a kite. Once we know that that's 110 degrees, let's make that replacement there so it makes it easier. And then we know 3 of the 4 angles in the quadrilateral, so all 4 of them should add up to be 360 degrees. So M plus 110 plus 40 plus 110, that way I don't miss any. Let's add those up to make it a little bit easier. Oh, almost forgot my angle here. My reason here, angle sum of a triangle. So don't forget to give your reason as you use it. Angle sum of a triangle. Now let's add those up. They're 260 degrees. Subtract 260 from both sides, and I find that that missing angle up there is 110 degrees. So I almost made a mistake there. I almost forgot my reason. So that way I'm showing my understanding of why I came up with that particular working to get that answer. So, example 2. Find the value of the pronumeral, giving reasons. There's my pronumeral. I don't have much information in this, but there's some important information. It's a trapezium, one pair of parallel sides. I could cover up that if I needed to. There's my transversal that doesn't go all the way through. It stops there. So if that's a transversal and parallel lines, these 2 angles are between the parallel lines and on the same side as the transversal. So what that means is that they are co-interior angles. So, co-interior angles means that when you add them up, they add to 180 degrees, which means they're supplementary. Don't forget my reason. Co-interior angles with parallel lines. Now let's subtract 74 from both sides, and I get that that missing angle there is 106 degrees. So a pretty straightforward one. I only needed to find that using my parallel lines. Had nothing to do with any of these other angles. So let's move on to example 3. Recognize the quadrilateral. It's a parallelogram. But they've given us an angle on the outside. That's 245 degrees. So if I went all the way around, I should be going 360 degrees, a revolution. So they have the same vertex there. Let's find this angle here first, W. So the 2 angles added together should make 360 degrees. So they make a revolution. But the reason that we give with that is that they're angles at a point. There's only 2 angles, but they share the same vertex there. And all together, they make a whole revolution. So angles at a point. Now let's subtract 245 from both sides, and I find that that missing angle in there is 115 degrees. So let's make that replacement just to make things a little bit easier. Now it's a parallelogram. What else do I know? Well, parallel lines, I can do co-interior angles and find this one because they're supplementary. And then I could use these parallel lines and do the same thing. Co-interior angles are supplementary. Or I could recognize that those 2 should be equal. That's also 115 degrees. Why? Well, the opposite angles of a parallelogram are equal. So I could have gone and found this angle and then moved on to that one, but I've just saved myself a little bit of working out by recognizing opposite angles of a parallelogram are equal. So let's move on to another example that's going to look a little bit more complicated. Okay, we want to find 4 pronumerals this time: x, z, y, and w. Does it matter which order we find them in? Well, no, but we try and look for some easy ones first. The shape is a rhombus. Opposite sides, or all sides, equal. The angles aren't right angles, otherwise it would be a square. Opposite sides are also parallel. So, parallel lines, transversal, even though it's a diagonal, it's also a transversal for those parallel lines. They're between the parallel lines, but they alternate from one side to the other, so alternate angles. So maybe we can use that to find W. So we can now say that W over here is the same as this angle here, 60 degrees, because alternate angles with parallel lines, because alternate angles are equal. That was a fairly straightforward one, but it took a little bit of recognizing there to start off with. Well, can we find any other angles? I don't have to, as I said, go in alphabetical order, but I'll find x next. X happens to be 60 degrees as well. This diagonal, remember from our properties of quadrilaterals, this diagonal should cut this angle into 2 equal parts. The words we use is the diagonal bisects the angle here at the vertex, this whole angle here. So we've said that it's 60 because they have to be equal. Why? The diagonals of a rhombus bisect the vertex angles. So some of you might have missed that. Okay, so you just got to be a little bit careful. But when we're finding angles in geometry, quite often there's more than one way. So you might have been able to find that it was 60 degrees using some sort of different method. So let's go and do y next. So y ends up being 90 degrees. How could I say that straight away? Well, there's something about our diagonals in a rhombus. Our diagonals are perpendicular bisectors. Bisect, we know, cuts into 2 equal parts, but perpendicular means meets at 90 degrees. So all these 4 angles here will be 90 degrees. Our reason? Diagonals of a rhombus are perpendicular. Well, that's great. So I found W, I found X, I found Y. How do I find Z? Well, it doesn't look like I can use my perpendicular lines at this point in time. But what happens when this diagonal cuts that diagonal? 2 straight lines meet, the vertically opposite ones are angled. Now there's no letter there, but I can actually write it down. So that's 90 degrees because they're vertically opposite angles. So I put that in my diagram. And now I've got a triangle in there. What do we know about the 3 angles in a triangle? Well, they should add up to 180 degrees. And why? Angle sum of a triangle. We do our bit of working. 90 plus 60 is 150. Subtract 150 from both sides, and z equals 30. So I did a bit of working out all there at once that you saw. But angle sum of a triangle. So just because we started off with a quadrilateral in the first place, you can see some triangles in there, and we can also use our triangles within that to help us. So as I said, there's quite often more than one way of going and doing things. So I could have said, well, that's 60 and that's 60, so that whole bit is 120. This big triangle here is isosceles because this side is equal to that side. And we know if there's 2 sides the same, there are 2 angles the same opposite those sides. Well, this is already 120. That's z, so that must be z also. And we can then use that rule 2z plus 120 equals 180 and solve it that way. So although I didn't do the working out, I just talked through another method to help us find out what Z is, and using this isosceles triangle in there. Okay, so that ends that 4 examples that we've done on some quadrilaterals.